Fine. So we look at the classes from the java.lang package, some the common classes available in the java.lang package, fine, which you very commonly will be required to be using. Okay. Yeah. So what are the classes we have been using so far? Yeah. Some commonly used classes, right? Yeah. What are the things we have used without writing an import? We use the string class. We have used the system class. What else? Okay. Okay. Fine. So these are the ones I think we haven't used much from this. Okay, we know the other things already. That's the object class, again from the java.lang package. Okay, which others? A whole set of classes which you know from the java.lang package. Okay, we call them as the wrapper classes. And the wrapper classes byte, short, long, float, and the boolean. Fine. Over and above this, yes, something about the string. A few interfaces. Let's see the interfaces. Yeah. Any interfaces which we know about from the java.lang package we have used? Anything? Interfaces, yes. What are the interfaces? Clonable. Okay. Fine. Clonable is fine. So we are concentrating only on the java.lang package currently. Otherwise, yes, a few more things. Yeah, which other interface from java.lang package? Okay. Yeah, of course, we'll say comparable of some type T. Yeah, which one? Achha, not from java.lang package. Okay. Anyway, iterable. Okay, yeah. Okay, there is this interface called iterable. Okay, of some type T, some element type E. Iterable of elements. Okay. Yes, we have this interface also, iterable of elements. And where is it useful? In the for each loop. So yes, if it's an iterable type, we can use it in the for each loop. Okay. So yeah, for each is applicable to arrays and iterable. Okay. Fine. Okay. Okay. A few other things. Something which are closer to the strings. Okay. I'll add here in this line. We have a couple of classes. Okay. We'll begin with what is a string. We won't be going through each and every class here, but yes, a few things here. String. Another class is the related to the string is this class called string buffer, and another class called the string builder. Okay, these two classes are actually same, and you can look at them as being almost equivalent. Okay, and it's only a question of thread safety and performance. Okay, that's where the two of them differ. Otherwise, the two classes, string buffer and string builder, are the same. Okay, fine. So let's begin with the discussion on the string class. Okay. Okay, so yeah, so what is a string? Let's see. Okay, another interface, because we are talking about string, there is also an interface called char sequence. Okay, we also have an interface called. Okay. So we also have this interface called char sequence. Okay, fine. So let's begin with the class called string. Okay, so what is the string class? What is a string? It's a
collection of characters.
It's a sequence of characters. When string is made up of is nothing but a sequence of characters. Okay, and it implements. So yeah, a few things about the string class. So what is a string class? Okay, and when I'm saying characters here, okay, what do we mean by characters here? That's a background noise, I think. Okay, fine. So when we are talking about character here, we are talking about the char type of Java, right? Okay, so what is char in Java?
ABCDEF 1234 dot slash.
Char in Java is nothing but it's a UTF
Is it type? Primitive,
16.
type. Oh, yes, sir.
Right? It's a UTF 16 encoded. Okay, fine. It's nothing but a character encoded as UTF 16. Okay, fine. So string is made up of UTF 16 encoded characters. Okay, now what we have here, let's look at the string class, right? How the header which looks like. So it says, okay, so it's part of the java.lang package, but if you look at the header, it says, okay, public class string. Oh, it's not a simple class. There are a few modifiers. It's a final class. Okay. So most of these classes which I have mentioned here, string class, system class, the string buffer, string builder, all these wrapper classes, they're all final. Okay, you can't create the subclasses. So except for something like object, okay, fine. Other things are final. Fine. Okay, whatever we have mentioned here, so they don't allow subclasses. Okay, so it's always a good idea unless you think that you should be having subclasses, fine, mark them as final. Okay, and so it cannot be misused. Fine. So okay, so string class is final. Okay, and it implements a few interfaces. It implements one interface called char sequence. That's what it is. Like, it's a sequence of characters. So char sequence interface is nothing but it's for any sequence of characters. Okay, fine. So char sequence, if I look at the char sequence, who implements char sequence? String. Okay, the two classes string buffer and string builder from the java.lang package. Okay, yeah, it's being implemented by other classes as well. Fine, but it's nothing but these classes are nothing but made up of a sequence of characters. Okay, fine. So if you, first we may have a look at the methods of char sequence. Yeah, which are the methods in the char sequence interface? So we have these. So any char sequence, it's nothing but made up. It's a sequence of characters with a limited number. So it says fine. All char sequence will have a method to return int. Name of the method is length. So that's a common method for all char sequence. Okay. Fine. Another one is to return a char value. Fine. Return, because it's made up of char values, given int position. Fine. Given the index, so indexes start from 0. Okay, fine. So if it's a sequence of characters, yes, these two methods actually tell about any sequence of characters. So if it's a sequence of characters, it's something like this. Okay. Now the difference between string and okay, and the classes like string buffer and string builder. The main difference here is objects of string class are immutable. What do we understand by immutability? And it cannot be, you cannot modify the state, right? That means if a string object is created with a particular sequence of characters, then there's no method which can manipulate that sequence of characters. Okay, fine. Okay, so keeping this in mind, let's see some of the common methods from the string. It's implementing, so methods like those are fine. These two kind of methods, they are always there, fine, to know how many characters in the string, and given index position, fine, you can find what character is there at the string, at that index position. Additionally, yes, okay, methods, or even before methods, let's look at the constructors here. How can we create the object of string? Okay, so to create a string object, yes, you can create a string object without any parameters also. Fine. So this is going to create a string with 0 characters. The length would be 0, and it's equivalent of this. Okay, fine. So it's equivalent of this. Okay, fine. So string can be created without any parameter. String can be created by giving a array of characters. Okay, fine. Or you have an array of character and you want to indicate a segment of it to be used for creating, you can say, okay, starting index and integer for the end index. Okay, so it's like in this array, so array may have maybe 50 characters, but you're saying, okay, starting from this index, use the characters to create a string from the array starting at a particular index and up to the given index. It's not included, fine, end is not included, fine, the end index is not included. Okay, so a string can be created by using a char array also. Okay, but then we also find constructor for string which says, okay, we can create it even from a byte array. Okay, fine. So you got some bytes and you can create it from a byte array. Okay, this is overloaded to also take as parameter a string, which is nothing but the character set name. Okay, so what is this actually? What is this character set name? Yeah, basically, if you are creating from a bytes, okay, right, then we have to use bytes because our data, it's a text data. String is always for text data. Our text data is not in UTF-16. Right? If it's UTF-16, that's a char type. Right? Char type is UTF-16. It's the same text data, but maybe it's in ASCII. or maybe it is in some other character set. Okay, so you indicate, yes, I have this bytes, fine. If it was UTF-16 encoded, then it would have been in terms of char. But if someone is saying byte array, fine, and he's saying it's a text data, that's why he's creating a string. Okay, in that case, yes, you should know what is the character set according to which the bytes are available. So bytes are nothing but encoded according to some character set. Okay, fine. So this is the character set, so it can be converted from a given character set. The bytes can be converted from given character set into the char. Okay, clear. So yes, there is something called character set encoding. UTF-16 is just one of the encodings, you can say, but native to Java is UTF-16 encoded characters. When Java talks about text, it talks in terms of string and char. Okay, so anything else, then we'll say, oh, it's bytes for us. In Java, it will be considered as bytes. Okay, fine. So that's something we should understand, right? Clear? Byte means, see why this is necessary, because when we say bytes, it's some other character set, and the value of the byte according to the character set, it will have to be converted into the equivalent char. It's not the value of the byte to be taken as it is. Okay, for creating the char values. So yes, there are some other classes involved, right, which are useful for converting bytes into characters and characters back to bytes. Okay, there are some other classes here which are useful, but we'll look at them at later stage. Okay, when we look at the IO package, java.io package, and there's something called a char set as a class again, but it's not in the java.lang package. We have something in the java.nio package. There's a class called char set. Okay, and so that's representing any character set, and then how to encode from the character set. So if we have bytes, and how do I decode from a character set or encode into a given character set? That would be possible. Okay. Okay, fine. So fine. So these are some common constructors. Of course, another constructor very commonly used is you can create a string by using a string. Okay, fine. So given a string, yes, you can again create a copy of it. Fine. But see, whenever we use a constructor, a new object is created. Okay, fine. Now something about the string constants. Yeah. See, string constants. What are the string constants? How do we write a string constants? The Java compiler will go through the entire code, look at anything which happens to be in two double quotes. Okay, for example, yes, something like this is there. Okay, then it is a string constant, right? What Java does is it maintains a pool of all the string constants. It's maintaining a string of a pool of string constants. Okay, so now in a Java file, okay, all the string constants which appear, they are in some common place known as a string pool. Okay, they are in a common place called string pool. So in your Java file, suppose I have written like this: string s1 equals, okay, and then we have a code which says, okay, let's have another string s2 equals, and someone says, okay, let's use, okay, fine. There are two usage of the same literal and same constant, string constant. Okay, so fine, in the Java virtual machine, it's not going to create two objects for the string constant. This fine. Okay, any usage of hello is only one instance. Any usage of a string constant is only going to be one instance. This is not a separate instance. Okay, the idea here being someone says is S1 double equal to S2, that should be true. Okay, but when someone says let me have string S3 equals, and now he creates a new string. Okay, fine, and that string is created from the same constant. Okay, and now if someone says S1 double equals S3, this is false. Okay, because you said new, it's anyway going to be a new allocation. Whenever we use a constructor, a new object is definitely created. Okay, fine. So any usage of this? Yes, this is nothing but these two are the same objects. Okay, fine. But when we use new, yeah, it's going to be another object. Okay, fine. Okay, so now let's look at some methods from the string class. Okay. Okay, yeah. So what are the things you might like to get from a string? So for example, yeah, given a string, you'll say, okay, so these are some methods, right? So there's a method to return a string. Name of the method is to uppercase. Okay, and similarly, another method called to lowercase. So what does it do? Yeah, what do these methods do? For example, if it's a to uppercase, what will it do?
Convert all the text into uppercase.
Okay,
All the characters.
yeah, but string object is immutable. So it's not converting. See, for example, if someone tries like this, someone says S3, okay, we have S3 dot to uppercase. Yeah, what do you think happens to S3? What happens to S3? Nothing happens to S3. Okay, it's returning a new string. Okay, fine. So you have to use something like this. Okay, fine. Clear? It's not a fine. Objects of string class are immutable. Okay, fine. Therefore,
Okay.
S3 is not equal to S4. That's another thing you should know. Fine. A new object is created. Fine. S3 remains as it is. Okay, clear? No change in S3. So methods here like this, which you may feel, oh, they are making changes. No, they are not making changes. They are generating a new string from this string only, using this string to create a new string.
Sir, is a string a reference tag?
Now, these are all classes, right? String is a class.
So when you said S1 equal to S2, won't it be pointing to two memory locations? Both have hello in them?
These are both referring to a constant. So whenever any constant is used, it is picking up, and that's one object. Okay, it won't create exactly same object twice in that constant pool.
Oh, it will just put the S2 pointer to S1.
Yes, S1, S2 both refer to the same constant.
Pointing to the same thing. But S3 will be a new because we use new, which is a constructor.
Because you called a constructor.
Thank you.
Okay. Right. So string S4 is equal to S3 dot to uppercase is nothing but resulting in a new object. Okay. So like this, fine. So we will have lot of methods. Yes, they are nothing but new objects which are fine. So string is never going to be updated. That's one thing you should know always. So that's why we say it's a objects of string are immutable. Okay, fine. A few other methods. Yes, what are the other methods we have? So we have this public method return string. Name of the method is substring. Okay, yeah, and when we say substring, we pass an integer as a parameter. Fine, we can pass only the start index. Okay, it's overloaded, so you can give the start and the end index, or okay, you may only give the start index, in which case it goes right up to the end. Okay, so if end index is not specified, it goes right up to the end from this index position. Okay, maybe if we have a string like okay, let's have a string s is equal to, okay, something like this. And now if someone tries string s5 is equal to s dot substring, okay, and yeah, you might say 3,7, yeah, what will happen? What will it result in? Index position start from 0, so what should it be? Okay, sorry, LO and space W. Okay, fine. Okay, so this is what the result of substring is, right? Or if someone says, let's use s5 is equal to s dot substring, and just says 5, let's say, yeah. Okay, so what will it be?
Space then world.
Yeah, space and world, and the entire thing, rest of the things. Okay, so when you give only one index, that's only one integer, it's the from that point onwards till the end. Okay, so substring can be there, uppercase, lowercase, fine, conversion to upper, fine, new string always, it's not converting anything, right? Okay, fine. What else we might need to do commonly with a string? Substring.
Concatenate.
Okay, so concatenation, we do have a method called concat to return a new string, but how do we do the concatenation? With the help of plus. Fine. One more thing to note here is, I was mentioning about the string constants, right? So if you have any, when I say string constant is made up of not only just anything like this, two double quotes. If someone has written an expression like this, okay, fine. There is any expression where a string concatenation is done, and if both of them are constants, then this is evaluated as a constant right there itself. So this is a constant. Okay, so if someone has this and someone has written like this, okay, fine. So if someone says string s7, okay, s6 equal to this and s7 equal to this, okay, and if I look at whether s6 double equal to s7, that's true. Okay, so string concatenation, fine, which involves, so if this was equal to like, fine, if it is like this, okay, but if someone had put, let's say, s5, right, where s5 was world, something like that, okay, yeah, suppose it was instead of 5, I had made it 6 here, okay, if this was 6, it would have been this one, right? And if someone had written instead of writing like this, if we had said, okay, S5, okay,
Yes.
then the
Yes.
two are not equal. Sorry, S5. Yeah, then the two would not have been equal. Okay, okay.
Why?
Clear?
Why? No, not clear to me.
Because this is any expression, a string concatenation, which uses constants, then it is a the compiler knows about it, right? So compiler is able to create the string pool for it. Okay.
But S5 is a variable and not a constant.
Yes.
Got it. Thank you.
So constants, yes, if you have a string concatenation involving constants, then it is evaluated and kept in the pool.
Okay.
Okay. So it's not that there are two objects like this. It's this is a third object you'll get. So one object for this string, another object for this one, and a third object which is a concatenation of the two. And that's going in the constant pool. Okay. Yeah. So okay. Yeah. And then we have, I think, one of the methods we used yesterday, probably. I think. Okay, so string, yeah, now a few more interfaces. Yeah, when we started, we said, okay, string implements CharSequence. Yeah, it's a final class which implements CharSequence as well as, okay, another one which we know of, comparable of string. Okay, there are a few other interfaces, but I'm not mentioning. There are, okay, one we can always mention. It's also implementing the clonable interface. Okay. Still another interface I will mention at this moment, java.io serializable. Right? Instances of string are clonable, serializable. These last two interfaces which I'm mentioning, these are applicable to arrays also. Okay, all arrays are clonable and serializable. These interfaces, clonable, serializable, these interfaces do not have any abstract method. There are no methods in them, basically. Okay, fine. They only enable certain activity. Okay. Oh, can the object of a class be cloned? Oh, if it is clonable, if it is marked as clonable, if it says it implements clonable, so there we call these interfaces as marker interfaces. Okay, these interfaces are marker interfaces used for enabling something, right? Okay, it's marked as clonable, it's marked as serializable. Okay, and so clonable, serializable, they are marker interfaces. Fine. Okay, so yeah, it is fine. It is comparable, so it's implementing comparable. So what other method we have? Public method returns int, name of the method is compare to, takes fine. When we say compare to, yes, it takes a string as a parameter because it's a comparable of string. Right? But also we used another method yesterday, and that was compare to ignore case. Right? It takes a string as a parameter, but it is doing comparison ignoring the case. Okay. Another one which you should know here is this is related to the comparator again. So we have one. This is not a method I'm mentioning, but I'm mentioning a constant. Okay. So there is a static variable. Okay. So we have public static final. Okay. And the type is java.util. I'm mentioning the interface, the package name here, dot comparator. Okay, comparator was part of java.util package. So fine, and name of the object here, fine. The name of the variable here is case underscore in sensitive underscore order. Okay, equal to, and of course this is initialized to some kind of a comparator which uses the compare to ignore case. Okay, this one uses the compare to ignore case, the way we had written yesterday, right? Okay, so this is one comparator. So the idea would be this, that if I have a string array, okay, having names in it, okay, equal to, let's not worry about how it has been created, okay, and it would be possible for someone to say arrays dot sort and say fine, sort these names, but use the string dot case underscore insensitive underscore order. Okay, so then your ordering of the names will be insensitive of the case, uppercase, lowercase will not matter. Okay, fine. So clear? Okay, so comparator is another one. So compare to and compare to ignore case. Okay, we even have the public method returns boolean. Of course, we have the method called equals where any object may be given. So this is because of the object class, we know this method. But what we also have is another method returns boolean. Name of the method is equals ignore case. And that would take a string, not any object. Fine. So equals ignore case. Fine. So some common methods which may be useful to you, and from the string class, these are available here. Okay, fine. So related to the case sensitivity, fine. So if you want, yes, so it's normally case sensitive, and strings would be case sensitive, but we have comparison operations which are case insensitive comparison operations available. Okay, fine. So yeah, any other you feel okay that there should be something like this? Yes, concat as a method is also there. So yes, we do have a method to do a concatenation. Public method return string. Name of the method is concat, and that would take another string as a parameter. I think okay. We may have a look at the string API. Yeah, from the API documentation also. But yes, more or less, these are some common methods I've mentioned. Okay, and we are not looking at the whole list of methods. Okay, fine. So string class, yeah, more or less like this. Okay, only thing you should understand that some methods, I'm not sure. For example, the concat may not be just about a string, but it may be about a char sequence. It will say, okay, you can give me any char sequence and I'll be able to concat it. So I'm not sure which methods, but some methods may work for, fine, where a parameter as a string is needed. Yeah, you can give a char sequence. Even the constructors, fine, you might have constructors which is taking char sequence. Fine. For example, constructor takes a string, but constructor can also take a char sequence as a parameter. Okay. So be aware of the type. When someone says char sequence, something is available for char sequence, you should understand, yes, we can use a string there. You could also be using string buffer or string builder type. Okay, so string is immutable. So small modification, if I want a new, oh, it will have to create a new string object. Right? But these are then, we say there is a thread safety. Okay, we have something called thread safety. Java is multi-threaded. Fine. That means there are parallel executions possible within the Java virtual machine. See, for example, when we run the main method, right? We dereference a variable. When we say dereference, what happens? We make an assignment. There's a reference type, it's referring to some object, and we reassign a new object. What happens to the earlier object then? Garbage collection. What do we mean by garbage collection? Fine. The space which was allocated for that object, because it's no longer usable by anyone anywhere within the application, it needs to be deallocated. It has to be deallocated. Okay, fine. So deallocating or destroying an object, fine, that's what has to happen. Okay, so how is this happening? Oh, it's happening parallel to the execution of the main. Yeah, our application is executing simultaneously. There is something in the virtual machine which is executing a code to identify such objects and deallocate the space which is available, fine, which that object is occupying. Okay, and make that space available. So there is parallel execution, right? Okay, fine. This is one example where we have seen parallel execution. Later we'll be seeing that when we write our application, we may have a parallel execution possible, right? So when there is a parallel execution, it has its problems also, right? Corruption of the data can take place, right? Because someone is updating a object, at the same time someone else is also trying to update the same thing, fine, then there will be, fine. So there are problems with concurrency. When we have concurrency, right, there are going to be some problems also. So we say, oh, this object is thread safe. It would mean it would not allow concurrent updation to the object. If it is immutable, there is no problem, because there's no fine, there's no problem related to thread safety. It is always a thread safe idea. Fine, this class is thread safe. Okay, but you may have a class whose objects are mutable. Example is string buffer and string builder. String buffer and string builder, these classes are nothing but they are mutable, right? They're not immutable. Okay, we are able to make changes, fine. But the difference between the two, that is the string buffer and the string builder, is string buffer is thread safe. String builder is not thread safe. String buffer is thread safe, fine. So initially Java was looking more at thread safety, fine, but then it affects the performance. Okay, because there is a process of acquiring the lock kind of a thing, so that no one else is allowed to update while I am updating. Okay, and therefore it affects the performance of the operations on a class whose objects are thread safe. Okay, so yes, thread safety is the cost of performance. Okay, and therefore we have the two versions of mutable char sequence, right? So we have these two classes. We have the class called string buffer, right, is thread safe, fine. Okay, whereas string builder says, okay, it's up to the user to ensure thread safety, but has a much better performance. Okay, so that's the only difference between the two of them. It's related to the thread safety. Fine. Initially, yes, the string builder came in Java 5. It was added in the library. Earlier we had only string buffer, or I think 1.4, it might have been in 4. Okay, string builder, introduction of string builder. Okay, fine. So string buffer, string builder, no difference at all. So if you want to create a string buffer or string builder, yes, you can create it from almost constructors are similar to what we have for the string class. Okay. So whether I say string buffer or string builder, it's the same. Okay. From API point of view, the library, entire set of methods, entire set of constructors, everything is same for both of them. Okay, now there's one more interface let me mention here. So if I look at the two classes, public class, oh, these are all final classes, string buffer or string builder. Okay, let me put string builder. So most commonly we now use string builder, fine, for the purpose of performance. And most of the time, if you have a local variable, then it is not going to be available for multiple threads at all. So we don't worry about multi-threading in such a case. Okay. Fine. So public final class string builder implements. Yeah, it would be comparable of string builder. Okay, and it would also be it also implements another interface which is again from the java.lang package, appendable. Okay, it's implementing appendable. So what do we have? We have the methods. What are the methods we are having? Okay, now here string buffer, string builder, both of them, they follow this particular strategy. The methods here, right? For example, this appendable. So we have this interface called appendable. Okay, and appendable has a method called append. Okay, so let me mention here, it's a public method, and I have not mentioned the return type currently. Okay, append method is overloaded. So you might append a byte, you might append a short, any primitive value can be appended. Okay, fine. Okay, not mention the return type yet. Okay. Okay, return type is the same. I have not mentioned it here. Okay, and we'll come back. And so it's available for all primitives. Okay, and as well as you can even append a char sequence, or you can append any object. So when any object is appended, if it is not null, O dot toString will be used. Everything is convertible to a string, so you get the string fine. Basically, all of these append involves string conversion. Anything which you are giving is first converted to a string, and then it is the characters are appended at the end. Okay, but what do these methods return? These return okay, fine. So they would be returning a string builder. What's the idea? Fine. You have some string builder SB. You can say SB dot append. Okay, so append something. Okay, dot append dot append. Okay, I've just shown an example here, but yes, the idea is you have multiple when method invocation is being chained here, right? multiple method invocation, and in single statement that can be done. So, right? So the methods in your string builder and the string buffer, they don't return void. Normally, instead of returning a void, doing some operation on it and not returning a value, it says, fine, we'll give you the object itself so that you can do a further operation on that object. Okay. Fine. So it's the same object SB string builder, some SB string builder is there, that is being updated all the time. Okay, same object being updated. Fine. Multiple operations performed on it. Okay, so yeah, so append is one thing. Yeah, what else would you like to have? We are saying, oh, this is mutable. Then if it is mutable, we should be able to delete characters in a particular range by giving the index positions. Okay, we should be able to insert characters. Okay, so all such methods would be there. We may have to take a look at the API. Fine, let's look at the API. That's better. Okay, fine. It's a module is java.base, and the packages which we have here. Okay, it's a java.lang package we are looking at, and the classes and the interfaces available here. Okay, we are looking at the class called okay. Fine. So we may have a look at the fine. So it says, see the difference between string builder, string buffer, and string builder. String buffer, it says a thread safe mutable sequence of characters. This is a mutable sequence of characters. And so the difference is about the thread safety. Anyway, let's look at the string builder here. Okay, and okay, the constructors. Fine. What are the constructors? Fine, a blank one. Okay, now when it says int capacity, right? Okay, what is it? It's like you have a blank sequence of there are 0. The length would be 0. Length 0 means there are no characters in this sequence. Okay, but when we say anytime our string buffer or string builder, both of these, they have a capacity. I mean, they allocate some space for characters, but there are 0 characters in them. Okay, so length is one thing, capacity is one other thing. Capacity is always greater than or equal to the length. Okay, some additional space has been allocated, not yet full. When that space gets full because of an append, okay, as you append, yes, it's appending within the capacity, but if it has to go beyond the capacity will be increased. Some block will be allocated further and the capacity will automatically get increased. Okay, so when we append, we don't have to worry about the capacity. Okay, but of course it affects the performance. If we know how many characters are going to be there maximum, fine, we may start it with a specified capacity so that it's not going to affect the performance later. Okay, fine. So that's one. Fine. So that's a capacity thing. Okay, so yes, from a char sequence. Yeah, string builder from a char sequence. Could be string, another string builder already, a string buffer. Fine, you can create it from a string. Fine, so these are the constructors here, and the methods. Let's look at the methods here. Yeah, okay, so okay, fine. At the top, I think we should have seen that yes, it is implementing the, what are the interfaces it is implementing? Okay, so it's implementing serializable, appendable, char sequence, comparable of string builder. Okay, fine, comparable of string builder, that's what it is. Okay, so yeah, looking at the methods, fine. So appendable. Because of that, it has all these. But now you can see on the return type is string builder in all these append methods, right? So append method, okay, okay. I'm not touching these few methods. Like there's a method called chars and code points. There's a method, I think, chars and code points. There should be a method called code points. Yeah, they return a int stream. Fine. This we will be able to understand later when we look at the streams. Okay, so at later stages we'll be looking at the stream. Okay, but both of those methods, they belong to the char sequence interface. Okay, it's there in the string buffer, string builder. Okay, compared to, right, now delete. Yeah, we wanted to know about delete. So delete from a particular index to the particular start index, end index. And whenever it talks about start index and end index, end is not included. Fine, up to the end index, but not the end index itself. Okay, so when we had used, what we had used was 3,7. It was 3, 4, 5, and 6, fine, which was used in the substring. If you recollect, we used start and end index. So any place it talks about start index, end index, it's going to be end index is not included, up to the end index, but not including. It's exclusive of the end index. Okay, fine. So delete method is similarly there. Deleting from a single, fine, deleting from a single position, fine, single character. Ensure capacity, that I need at least this much capacity. Okay, fine. Get chars, yeah. So this is like okay. Okay, so here you can see what is this get chars basically. Okay, it's nothing but a method which says, okay, you are passing a array as a parameter here, a char array. Okay, and you are specifying a destination index. At this index, in this string builder, insert the characters from this array where the begin and end is given. So a segment of a char array, from there pick up the characters and insert at a given index in this string builder. So mainly these are methods which are affecting the, so additional methods are there and which are nothing but affect. So insert method, you specify the offset, and you could be like append, right? You could be inserting any primitive type. So when you insert, there is a string conversion involved, and then the char sequence is picked up. Okay, fine. We understand every type can be converted to a string. So appendable, yes, it was overloaded to use all types. And same way, insert also. Fine. Here with insert you specify a offset. Okay, yeah. Okay, another method. Now this is also a method of string. Okay, so I think let's discuss this method also. See, we had a method, so I'll go back to the string here because, yeah, but it's again available for the string buffer, string builder as well. Okay, so we had the method called char add, right? What was char add? But we had the char add method, right? Which gives us a character. It returns a char at index position, right? Now it's the other way around, right? So we have this method, which returns int. It returns the index value, and you can say index of, and you can specify a char. Okay, what is the index of this character in the string? Okay, fine. This is overloaded. Anyway, I'll mention how it is overloaded. So for example, if we had that string s is equal to Okay, if this was my string, and if I say s dot index of, okay, if I ask for what's the index of L, what will it be? Yeah, this is going to be, at what index does the L occur in this hello world? 2. And it's going to be 2. I call this method again. It's going to be 2. It doesn't change. Okay. Yeah. You wanted to know the second one. What's the second position? Oh, you got the index answer as 2. What you should now do is, okay, fine. You can use the overloaded method. You can say, okay, index of, okay, from a given starting index. From this index, find this character. Okay. So you could then say, okay, let me look from 3, index position 3, and it will return 3. It won't say 0. Okay. Index in the string. And what it returns is the index position in the string. Fine. So you're actually restricting the search. So you are trying to find, and index of is nothing but search a character. Okay. Fine. If I say, fine, let's say s dot index of, and I think we'll have to just change the sequence of the 2 parameters. First is the character and then the index. Yeah. So s dot index of L comma 4. Yeah, that should be 9. Okay, fine. And if someone is saying, okay, yeah, you are starting from index 4. This is index 4. So 4, 5, 6, 7, 8, and this is the 9. Okay. Okay. What about this s dot index of A? That would be, if it's not there, then it returns a minus. Right? If not found, returns a minus 1. Yeah, not found, then it is minus 1. Okay. Now, just like we have this index of, okay, index of is overloaded to use a string here. You might give a string as well. So you can locate a substring, the index of a substring within a string. Fine. In a string, you want to locate a substring, so that can also be done. Okay. Fine. Further overloading, let's see. No, not further overloading, but both of these, all the 4 methods, okay, have an equivalent method in a reverse direction. Okay, so instead of saying index of, there's another method available called last index of. Yeah, so what is s dot last index of? L. That should be 9. Fine. It searches from right to left now. Okay. In the string, search from right to left, but return the index position. Okay. So starting from the highest index, it will start searching the. So, fine. So just like index of, there is a method called last index of, overloaded in similar manner. Okay. I'm not updating the example now. I think you understand this, right?
Yes.
Oops. Yeah. Okay. Fine. So exactly same methods available for, similar methods available for string buffer, string builder. Okay. Fine. Other than append, yes, the methods were delete, insert, okay, find some other method, right? Index of, last index of, those methods anyway, they are available to whatever is available for a string. Almost similar methods would always be available for string builder. Fine. String builder has additional methods where we can make changes, updates. Okay. We even can do a replace. Okay, like insert, there's also a method called replace. Okay. Fine. So where we can replace a segment or all occurrences of a string, a particular substring in the entire string builder rather. Okay. So yeah, you can look for those methods in the API. Fine. Fine, clear? String buffer, string builder. Okay. Like this, another class. Oh, I didn't mention the top. Let me put the in my initial list. Very important class here, which is part of the java.lang package. There's a class called math also. Okay. We have this class called math. Okay. Fine. Anyway, public and final class math. Okay. It doesn't have to implement any interfaces or anything. Okay. It is full of only static methods in this. Okay. What are the kind of methods we have here? Okay. Before going to the static methods, there are two constants. These are related to the math, right? So we do have public, static, double, okay, and the value for pi. Okay, we even have public, static, final, double, e. That's a Euler's constant. Okay, some 2.72 something is there, right? Then, okay, yeah. What other methods do you expect? Okay, you can do something like min. Oh, static method. Sorry, I forgot that. Okay. You can do something like min. Okay, takes to double. Fine. You can do a min. You can do a, I think not min max. No, min max don't come here. But we have mathematical methods. Yeah. What are the mathematical methods? Trigonometry, sine. Okay. These would work for double. Okay. fine, and would be returning a double. Sine, we have the method for the cosine, and there's a method called tangent, fine, A10, they call it as A10. Okay, fine, I think we can quickly have a look at it in the API, fine. So yeah, there's another one, I think UTP, okay, okay, let's look in the API, I think that's better. And let's go to the package. So in this package, classes and interfaces, and the class called the math. Okay, well, no constructor kind of a thing, but methods which are there, it's all static methods only. So finding the absolute, fine. Okay, and methods would have been for int, long, double most of the time. Even for float, they have provided int, long, float, and double. Fine, we know anything smaller than an int gets converted to an int type. Okay, fine. A sign, I think the arc sign, I think there is A sign, A10, fine. Cube root, CBRT, square root, SQRT, ceiling, fine. For a double, if I say ceiling, what does it mean? Ceiling is returning. What's the return type for ceil? Method is, okay, it's returning a double, but yeah, it's returning as a double. Returns the smallest, closest to the negative infinity, double value that is greater than or equal to the argument and is not equal to a mathematical integer. Anyway, these are all mathematical methods, fine. Okay, decrement, divide, floor division. FMAN returns the fused multiply add of the three arguments. Anyway, so yeah, get exponent from a double, get the exponent part. Okay, okay, log, finding the log to the base 10 also. Okay, yeah, max min is there, sorry, yeah, we had the max min for overloaded for the primitives, fine. The it would be available for int, long, float, and double. Max min multiply okay. Another one here is the method called random to give you a random value, fine. Generates a random generate a random integer. Oops, sorry. UTP rounding scale square root was this, sine subtract exit. Okay, ULP, yeah, that's another one which is available for double and float. Okay, what is ULP? We understand float and double are imprecise, fine. They are not going to be very precise, right? And as you go away from zero, the level of precision is falling exponentially. Okay, so this ULP is giving the distance between this double which you are giving and the next double which is possible. What's the distance between them? So you know that at this place, what is the level of precision you are getting? Okay, see, I can just quickly show you a quick example to know what is ULP. If you recollect, we had seen this, right? That, okay, we have a, let's use the float here. Okay, we understand it cannot exactly be stored in this. And if I say f dot ulp, that's giving me, sorry, math dot ulp. It's a static method, it's not on the object. Math dot ulp, give the value float, and says 8. And the distance between this value and the next possible float which I can have. Okay, see, if I had done it with a value like 1, that's a very small value. Okay, and if I do it with, okay, yeah, if it's a 8-digit number, we get a ULP of 1, as good as an int type when it's a 8-digit. Okay, fine. Anyway, so this is nothing but a whole lot of methods which are available for all mathematical things. Min max of 2, okay, between 2, which is the minimum, which is the maximum, that's available here. Okay, and again through static methods, all static methods. So math dot, very commonly used is that constant math dot pi. Okay, and trigonometric methods and logarithms. Okay, so anything like this, if it is needed, yes, square root, cube root. Okay, 10, fine. Okay, rounding, yeah, rounding is also available. And you can do a round to a long, from double round to a long, from float round to a int. Fine. Rounding is possible. Fine, get the rounded value. Nearest round, fine. Rounding we understand, right? 0.5 thing. So if it is 10.5, rounding will give us 11. Okay, 10.4, rounding will be 10. Next down, next up. Anyway, so may not be needed most of the time. POW to get find power of, find a raised to the power. So a raised to the power of b. So that is what you can do with POW. Okay, and so lot of such methods are here. Right? This is in the so math, right? This is the java.lang.math class. So again, commonly used class. And it's not so many methods are not always going to be useful to us. And, but some of them, fine, you should know the min max, fine, those things. Sometimes they may become handy to you. Okay, min max kind of things. Okay, then what we have are the wrapper classes, right? Okay, so now fine. So before going to the wrapper classes, we have one more topic in between. Okay, then I'll pick up the wrapper classes. Okay. Fine. So next thing should be about the, yeah. Next what we look at is the exceptions. Fine. So next topic, our next topic is going to be on exceptions. Okay. Fine, but yes, this is just to introduce that you should see. You can always explore these APIs, right? The documentation. All of you have been able to download that documentation. There's a zip file which is available. You can download, right, from the Oracle site. Okay. Fine. So this API documentation is there, but yes, these are the common classes you should be looking at, right, in the java.lang package. We have done comparable earlier already. Fine, that's in the java.lang. Comparator is part of java.util package. Java.util also has the class called arrays to deal with array. Okay. Now, sorry. Okay. So next thing, yes, we'll look at exceptions. And okay, let me also show you after exceptions what are the next things we will be looking at. Okay. The flow is going to be like this. Go through the exceptions, then we may go at the wrapper classes. Okay, so we finished the java.lang package, most common things which we use, right? Then we will go towards the nested types. Enum. Okay, along with that, yeah, maybe we'll take enum and the nested types. And so that's for the next few sessions. What is the sequence we have for that? Fine, so yeah. And so today it was mainly on some methods and classes, right? But yeah, tomorrow it's going to be on. This is conceptual things now. Okay. Fine. So for APIs, yes, I'll only say you have to refer to the library. Just go through them. Be familiar with what kind of things are available. You may not remember all the things, but yes, you should be having idea what kind of methods are available in which classes. Okay. Yeah. So, and so that's for today. And tomorrow we'll look at the exceptions.